Hey everybody, my name is Sam. I'm your instructor. If you are meeting me for the first time right now, then you should stop this video and go back and watch the recording of the first class. If you're seeing me for the first time, it probably means that you weren't in that first class, which is where I guide the students through setting up software and writing the Hello World program. So you need to go look at that and make sure that you have the software set up and that you can run Hello World before you take a look at this video. Okay, so you'll find that in the modules section of Canvas under recorded Zoom classes. Okay, so if you go into the modules section here, this is where you will find the recorded Zoom classes and the week 1 stuff that we're looking at right now. Now, if you go into the README here, you should always start here. Most of these, this is a 5-hour course, so you're expected to spend 5 hours or more a week on this. Most weeks will have an assignment. This week just has an ungraded assignment 0, which is kind of a get-to-know-you assignment. And then so there'll be 4 chunks of content, one for each of the hours, and then a 5th hour where we introduce the assignment. This week there's 5 chunks of content because we don't have an official assignment. So we already did the first chunk, which was the course introduction in Hello World. And now we are into variables input and output. And this may look a little bit overwhelming, but it's pretty simple. Each section just says, read the section, watch the video, and then it recommends one exercise for you to try from the exercises document. Learning to program, as I probably said in the first class, is really all about rolling up your sleeves and actually just doing some programming. So I curate these exercises here to give you one to try, but don't stop at one. Try as many as you have time to try. The more code you write, the better a programmer you'll be. It's as simple as that. And if you run into any problems with any of these exercises, you should email me. You can always send me a zip file of your code, and I'll take a look at it. I try to be quite available, so I usually guarantee a response within 24 hours, unless it's a weekend because I have a family and often I'm busy on the weekends. But other than that, I will respond as soon as I can. Okay, so go back to the modules here. Just I won't go through the modules on every single video, so this video might be a little longer. I just, the first couple of times through, we need to kind of reinforce everything just to make sure everybody's on the same page. You've got your README, which tells you what to do. Then there'll be the videos for the week. Classes are up here. So actually our first video for the week was the first class, which will be in recorded Zoom classes. Then there's a guide. The guide is a complement to the textbook. So if you download that, here's what the guide looks like. Let's scroll up to the top. Usually it recommends some textbook reading, and then it links each section to a section of the textbook. So in class we did the Hello World section here. The textbook, what you want to do is kind of find a happy medium between the textbook and the guides. The guides are really, really basic. This is the minimum that you need to know to get going. And to do what we're asking you to do and to learn the basics. And then the textbook goes into probably way more detail than you need to pass the course, although none of it is irrelevant detail. It's all useful stuff. So if you've got the time and the ability and the interest, you should read those textbook sections. It'll also give you another view of the same material, so it'll help your learning by presenting the material to you in a slightly different way. Okay, so there is an expectation that you've done the sections. You've done the reading, these particular sections. Okay, even if you just skim over it to see what's in it, it's worth doing. All right, so here's where we are right now. So we've already run our first Java program using IntelliJ and the Liberica release of Java, and now we're going to take a look at variables and input and output. So I'm going to start up IntelliJ here. And I'll walk you through creating a project and downloading the code. Again, I won't do this in every video. I just think it's worth the first couple of times doing it. So I'm going to create a new project. If you already have projects open, then you'll get that project opening up. You might want to do one project per week or something like that to keep your code organized, or you might want to do a different project every time you code. When I hit the new project button, or if you're in IntelliJ, it's under the file menu, new project. It's going to want you to pick the SDK. This is the compiler, the software development kit. Make sure you're picking the Liberica one. Just get used to doing that. It's not that important for this lesson, but for the next lesson we'll be doing graphics. You'll need the Liberica one, which comes with the graphics bundle. Otherwise you won't be able to do what we're doing. Okay, so really important that you have the Liberica release. The version's not so important. 15 is the most recent one as of me recording this. 14, 13, even back all the way back to 8 will be fine, as long as it's the Liberica full version. Okay, I go next, next, and then I just need to name my project. You can choose where it goes here as well. I'm just going to put mine on the desktop here so that I can find it easily later. Not the best place for projects, but for me these are very temporary. I'm just going to zip it up and load it and upload it later to give you some example code. So let's call this variables and input. Hit finish. Okay, directory does not exist. Oh, wait, I don't want that. I want this to say variables and input as well, actually. So finish, says the folder doesn't exist. That's fine, create it. And I get this, just a big blank screen. If I go over to my desktop, which is where I put it, you'll see the folder here. And you can see it's telling me the path here as well. And inside there, your code is going to be, don't touch any of these other files, but inside the source folder, SRC folder, that's where your code is. This is a view from Windows Explorer, and then over here you can get the view here as well. So click here and you'll see your code. There's no code there right now. What you may want to do is every week has example code. So let's just go through that process. See, there's so week 1 here has the example code. So if I download that, you may want to be able to run that code. So I download it. It's a zip file. I can just click here to open it. When I open it, you can see that I'm inside of a zip file. You can't really move things over from here. So I'm going to copy this and then I'll put it on the desktop. Control C or right click and copy. Then go over to the desktop, Control V or paste. There it is. Just putting it here temporarily because I need to extract it. I need to get it out of the zip file. And then in there you'll find a package. A package is just a folder. This is a folder of code. See, these are all .java files. And it contains our program templates and stuff like that. So the easiest thing to do, you might be tempted to just drag it over here. That's not such a good way to do it because if you do that, it will actually remove it from this folder and put it in this source folder over here. So what you really want to do is copy it. Just get used to copying it so that you don't accidentally, if you're moving files around, you don't accidentally delete them. So I copy that and I can paste it either here or here directly into the folder. So if I right click here and paste, there it is, paste. It's giving me some choices here. That's fine, just say okay. And you can see it basically just puts the folder right here inside my variables and input project, but now I can see all the stuff here. And there's a sample happy hello world here. Which I should be able to run. Once you see the green play buttons here, you should be able to run the files. So if I right click, I can run it, or with Control Shift F10, I can just run it. And if you're just setting things up, or if you're just running for the first time, it takes a little longer sometimes to run the first file. So you can see this. All this thing does is prints out hello world. There we go. So what I want to do now is I want to create a new program because I'm going to show you how to use variables by creating a new program. You might notice, by the way, that there's a new folder here called out. This is where the output files of the compile process go. So if we are if we're over here in variables and input, this is our folder. You'll see there's a new out folder there, and if you go in there, you will find the .class files, which are the compiled versions of the files that run. So just ignore that folder. We're going to do some work in the source folder here. I'm going to create a new, by right-clicking here, I'm going to create a new package of code for my code. I think I'm going to create a tip calculator. I know there's already one created there. Just want to walk you through that process in a tutorial way. Now you can follow me if you want and code, or you can just watch. I'm going to go pretty quick. Just watch and absorb, and then try and do your own programs later on. It's up to you how you want to approach this. So I'm going to call my package tipcalc, like that. Now I have a new package, which is a new folder in not in there. If I go into desktop, variables and input, and source. There's a new folder in there now, tipcalc. And I can right-click again and say I want a new Java class, and I want to call it tipcalc, like that. Okay, and that creates me a new class. Notice the package declaration is already there, and the class name, public class tipcalc. Everything has to go inside of these curly brackets. Okay, and notice it's auto-indenting for me as well. Now, if I want to do anything at all, I need a main method, and the quickest way to get a main method is psvm tab. This is the actual syntax for it: public static void main string bracket bracket args. This, we're going to explain what this, by the end of the course you'll know what every word in this line means. For now we're just going to treat it as magic words that we need in order for our program to run. This is a method, which is the same thing as a function in Python, but in Java, in object-oriented languages, we tend to refer to functions that are inside of classes. We call them methods. Okay, so this is our method, and let's take a look at what we need to do here. So we're going to need, basically we want to have a dialogue with the user for this. So we can say something like this. We can say system out print line to put out a prompt, or sout tab gets you a system out print line like that, which is really nice. There's a bunch of these little shortcuts. They're all built into the IntelliJ IDE. So we can say restaurant name, and then we need the user to enter the restaurant name for this tip calculator. Now, what do we need for that? Well, we need a variable. Now, in Python, you were able to just do something like this. You could say s equals hello, and that creates a variable. Notice the red here cannot resolve symbol s, so it's flagging an error here. You can't do this in Java. Java requires you to declare every variable that you're going to use. Okay, so variable declaration means you have to give the variable a type name, and that type declares what type of value that variable is going to hold. This is quite different from Python. If we take a look at the examples over here in the guide, in Python you can assign 5 to x once, so this is an integer, and then later on you can change your mind and assign a string to it. Here the variable holds a value of type integer, and here it holds a value of type string. You can't do that in Java. This is called dynamic typing. It's popular in scripting languages and in languages that they use on the web. It's great for quick prototyping. Python is built to give you flexibility to quickly create prototypes, which is not to say that people don't also produce serious software with Python. Google comes to mind. A lot of Google's backend is written in Python. But it was intended to be flexible, dynamic, expressive. Java and C# and C++ and object-oriented languages are written with a different kind of goal in mind. Their goal is to force you to write code that is easier to maintain and easier to debug. Okay, so in Java, you'll often find yourself a lot more constrained in what you can do, but there's a reason for it. And the reason is that the more you constrain the user, the more complicated you make the syntax, actually the easier it can be to debug, because a lot of errors, which in Python would be runtime errors, you wouldn't notice the error until you ran the program and it didn't do what you expected. Those errors will be caught early in a language like Java, because a lot of them will be now syntax errors. So the program won't even run, and it will be able to give you a nice message telling you what's wrong with the program. So one of the ways this manifests is that we have what are called statically typed. So dynamic means it can change, static means it can't. So what you have to do is create a variable by declaring its type up here. So int is the keyword in Java for integer. So this example is creating x as an integer variable. So it can only hold integers. This is a concept that doesn't exist in Python, an integer variable. Any variable can hold any type. So that means we can assign integers to it, but we can't do this. This is a syntax error. Okay, so it forces us to make sure that we know ahead of time what we're intending to do with our variables, and we have to stick to that. This is also a syntax error because we have not declared y yet. Okay, so there are a number of types. Do I have them here? Yes, down here in this other example, you can see an int variable here. You can also see a string variable here. And maybe I don't mention it here, but there is another type. The type that you need to use here for this line is double. So those are the three types that we're going to use right now. Int for integers, string for strings, and a keyword called double for variables that have floating point components, so variables with decimals. So we're going to go string like that. Okay. If we want to create a variable that has a decimal component, we can do this, double y equals 2.3. You can do this separately as well. So you can say string s, and that this is the declaration part of the line, and this is the assignment of a value. You can only do the declaration one time though. So you'll often see me do this shorthand where we do declaration and assignment in the same line. But you can't do that again. You can't then go string s equals, Sam, like that. This is an error. If you mouse over here, it says variable s is already defined. So once you've defined the variable by declaring it of type string, you don't declare it again. You can continue to assign to it. Okay, so this is a double variable, y equals 2.3, and I can have an integer variable x equals 5 like that. Okay, so these are the three types we're going to use. You declare again by putting the type name here, and then the variable name here, and of course you have to put a semicolon. Every statement ends with a semicolon, and then you assign like this, x equals 5. Notice the casing here. Int and double start with lowercase. String has to start with an uppercase. And you'll notice that these types are colored in blue in IntelliJ, and this is black. The capital S indicates that this is an object type, not a primitive type. We're going to talk a lot about that later, but for now we can ignore it. Just keep in mind that if you put lowercase s, you're going to get an error. Cannot resolve symbol string. That just means I don't recognize that word because it needs to have a capital S. Now it recognizes it. Okay, so that's how you can create variables. You can print them out. Let's do another system out print line. Whoops. Sout like that. System out print line. You can say x is, and then you just use the plus operator like that. That's a little bit different from Python, where you would use a comma like that. That doesn't work here. What we have to do is the print line method only takes a single string, so we have to concatenate things together. So this is the concatenation operator. It will take whatever x is and concatenate it onto the end. If I copy this and paste it a couple of times, I can do s is plus s as well. This works for any type. So if I run this, which right-click, Control Shift F10. Restaurant. Okay, so I started doing the tip calculator and then I got sidetracked. But this is the restaurant. This is the first line here, and then it's printing out the names of these variables, 5 and Sam. Okay, let's back it up here and take a look at what it would take to write this little tip calculator program. So I need a string for that. Let's call it restaurant name. So we're going to follow the best practice of naming things in a descriptive way. When you're creating variables in Java, really important that you start those variables with a lowercase letter. That's a documentation standards issue. The only things that start with capital letters in Java are the names of objects. The names of classes. So every time you see, when you create a class, you should name it with a capital letter. Anytime you see something with a capital letter like string, you know that that's the name of a class. Everything else, packages, variable names, this is a method name here, this is a method called main. Everything else starts with a lowercase letter. And the usual convention for the Java programmers adopt when they're naming is to use what's called camel case. So even if the first word starts with a lowercase, every subsequent word inside the name starts with an uppercase letter. So tipcalc has a capital T and a capital C. Restaurant name, because it's a variable, has a lowercase r and a capital N. Okay, so that declares the name variable. And I'm putting a comment in here with a double slash here. It's just a single line comment. Now I need to get input from the user. I need to read in the user's input. So the way that you do this is you have to create a special kind of object called a scanner. Okay, so here I'm declaring a variable of type scanner. Scanner, as you can see, starts with a capital S. It is a, don't worry about the error for now. it's an object type. It's a class name, and I'm naming a variable called input, and I'm going to assign to it. Now, the rest of this you can basically just treat again as magic words, but we're going to learn a lot about what the rest of this stuff means later in the course. System.in is basically an alias for the keyboard. So I'm going to create a scanner object that reads from the keyboard. That's what I'm saying here. And this is all red. It says cannot resolve symbol scanner. Notice it's giving you the chance to import the class. So the problem here is that some parts of the Java contains thousands and thousands and thousands and thousands of classes, and you don't want to load them all to run every single program. You just want to load the ones that you need, otherwise your software becomes bloated and big. So most classes that we use, some classes are built in by default, like string. But most of the other classes we use require us to explicitly tell the system that we are importing this class. And you can see when I mouse over here, I'm getting all kinds of hints. Java.util scanner, this is the one we want. This is the class that we want to import. And if I just go Alt-Enter here, see it's telling me to do that, it puts a little import line up above. Import java.util.scanner. So that fixes the issue. Okay, so usually when you first type the name of a new class, it'll flag it as red. Just finish your line, and then it's usually pretty good at figuring out which class you need it to import. So this is inside of a package called java.util. It's a class called scanner. So now that we've imported it, we can use it. Okay. Now that I've got an object stored in a variable called input. I could have called this whatever I want. I often call mine SC. We'll just call it input. Now I can use it. It has a bunch of methods in it that let me read from the keyboard. And basically, when I hit dot, it starts giving me these options here. It has a method for each type, right? So if I'm inputting an int, I have to use next int. If I'm inputting a double, I would use next double, and so on. So what I can do now is I can declare, I've declared restaurant name. So now I can, notice it gave me a hint there, so I just hit tab to get restaurant name. Restaurant name equals input dot, and it's really smart about giving me options. This is what I want. Next line is for strings. It lets me read a line of input and put it inside the restaurant name. Okay, let's run this. So it's Control-Shift F10, I believe, right, to run it. So it says restaurant name, and it's waiting for me to say, Bubba's. Okay, and that's all it does. It just gets that restaurant name and then exits. But it's stored it inside the restaurant name variable. Okay, now we want to say system.out.println amount of bill. And this time we want it to be a double. So string amount, sorry, not string. Since we're doing money here, and I'm going to do this all on one line, input dot next double. I just hit tab to do that. So get used to hitting tab a lot and using all of those suggestions. So now I'm having them enter the amount of the bill, and now I'm going to go, I should be using sout here, system out println, tip percentage, and this is going to be, I'm going to assume that this is an integer. Most people think in terms of integer tip percentages. Percent equals input dot next int. So that'll get me my three things, and if you want to see them, so it's always a good idea to write a few lines and then run. That's just a good tip. So you can a good tip for writing code. If you write too many lines and then run it right away, so I just copied that 3 times. If you write too many lines at once, then it becomes harder to debug, because if you've just written a few lines and it's broken, then you can be pretty sure that it's the last few lines that you wrote that were the problem. Control-Shift F10 here. We'll run this code, so I can say Bubba's. The bill was $99.99, and I want to leave a 15% tip. So it's not doing anything. This is just the input phase of the program, but it's echoing back to me my results. Now I just need to do a little bit of a calculation. The calculation that I need to do here, actually let's make this, should I make this a double to keep it easy? Yeah, I think we'll get ahead of ourselves if I make this an integer. Let's make it a double. So the percentage will be a double. I'll explain why later on when we talk about data types in a future video. So I'm going to make this a double, which means I have to make this a double, like that. Okay, there's a lot of details I'm glossing over here, but we're going to come back and fill in some details later. So then I just want to do some processing here. I want to create a total, which is going to be equal to amount plus amount times percent divided by 100. I think that's the correct calculation. So you divide, so if the percentage is 15%, you want to multiply by 0.15 and then add that on. There's a couple of other ways to do this calculation. But then what you do is we can print out the result in a system out print line. Your total, you should pay, and then we'll go dollar plus total 2 plus restaurant name. How about that? Plus dot. Okay, so this is how you piece together multiple bits of information in a single string. You just add them together. So a little string fragment plus the variable plus another little string fragment and so on. Okay, so that outputs it. I think I might have shown this to you before, but if we go under code, reformat code, Control-Alt-L, this is something that I do a lot as well. Control-Alt-L will re-indent the code, and you notice when I hit it, you may have noticed if I go Control-Z, see it spaced everything's out for me. So hit Control-Alt-L a lot. It spaces out your code, it makes it look nice and so on. This should work. The best way to test this, I can hit this button up here, by the way, to run the current file, the one that's here. So restaurant name, Tim's. Amount of bill, let's keep it simple, $100, tip percentage 15. You should pay $115 to Tim's. Notice it's not, so that it seems to have worked. 15% of 100 is 15. So it seems to be working. Let's try it with some other numbers. Restaurant name, let's go back to Bubba's. 23.32, and I want to do a 13% tip. Okay, now you might be noticing here this isn't formatted very nicely. Let's go back to the guide here. So we've covered most of what's here. Int, declaring variables by saying the variable name and then the variable type and then the name. We've looked at 3 types: int, which is on the sheet here, string, which is on the sheet here, and double, which is not here. Double is for variables with numbers with decimal places. I've covered most of what's here. We did the import. We used next int and next double. Oh yeah, I showed you next line. You can also use next, which just gets a single word. Next line reads the whole next line. There are some gotchas about using next line though, about getting string input. For now, let's just say it's easier to do your string input first and then do your numeric input. There's a gotcha section in the textbook in section 2.3 that explains it. And I can also go over it in class as well to explain what the gotcha is. But take a look at that. And how to print out. Oh, there's also a system out print. Maybe I should show you that. So you notice here that in this conversation, when I say restaurant name, and they're always typing down here, amount of bill, but the typing appeared down here, might be nice to put the number there. I can do that if I change this to print. So print line, print ln, which is pronounced print line, prints the text that you give it and then attaches a carriage return on the end. So the next thing that gets printed is going to be on the next line below. But if you do system out print, it doesn't attach the carriage return. And that can be kind of nice. So let's run this again. Saying restaurant name, Sam's Place, amount of bill. So now notice the cursor's here, which is kind of nice. 44.53, tip percentage 15, and then it's telling me I should pay. Yikes. Okay, I need to fix that. I will. Right, so system out print has that nice property of not going down to the next line. So the next thing that you print or the next input you take is going to be on that same line, which is kind of nice. Okay, and then the last thing that we need to talk about here is formatting output. There is a special method for that, system out printf. Again, this is kind of optional, but you can see it in section 2.3 of the textbook, and you can see it also in the sample code, I think in the tip calculator that I put online. But this is how it would work. I think if you go, yeah, SOU, wait a minute, let me see this here. Oh, this is nice. So this is showing me the shortcuts that I can use here. SOUF, if I use that one, is system out printf. So this is a weird little command that goes way back to the original C language that all these languages like C++ and Java and C# are based on. It's a way of formatting a string. So you can say you should pay $, and then you're going to put a format code here, and then you put a format code here. Okay? And then you tell it afterwards what variables to fill in the format codes. So what I'm doing here is kind of optional, but it's kind of a cool thing, and it's not that hard to master. So you put a format string here which contains text, and then I'm going to fill in these blanks with special format codes, and then you put a comma and the variable names, and each variable goes in order into those format codes. So for example, to output 2 decimal places for a floating point number, it's %.2f. Okay, so the percent means this is the start of a format code. F means floating point. So this is a double, which is a floating point number, a number that has a decimal portion. And the .2f means give me two places after the decimal. And right here, this is a string restaurant name. The code for that is %s, I think. I think I did this right. Let's see what happens. So let's do the same. Sam's Place, 4453. And I left in both lines so you can see the difference. And 15%. So the first one where there was just using system out print line gave me this, but now I've nicely formatted it, rounded to 2 decimal places by using this code here. Okay, and I think I have a tip calculator here online that does basically exactly the same thing. Yeah, I used an integer here, and it worked out okay because of the way that I've done the calculation. So here, this is maybe a nicer example, the pre-baked one, because it's showing you the string, the double, and the integer, the use of system out print here. And then I put some notes in here, so I've commented out the system out printf that shows you how to format this more nicely. So there's that. I'll zip up and post tipcalc online as well, so that you guys can take a look at that too, the one that I just did today. I'm going to comment it though before I do that. Like this, /** lets you enter a header comment. I'm just going to say example tip calculator from video. Author Sam Scott. And that's enough for now. Okay, so that's pretty much everything. Hopefully, I think we went a little longer than we normally will on these videos. But what I would like you to do now is, if we go back into modules and the README, there's a suggestion here for an exercise. It says try 2B or similar. So it's really up to you what you want to do. But I'm suggesting that you try exercise 2B. This is using the thread.sleep method that we looked at in the live class. I want you to ask the user to enter an integer x, then print a line of 10 plus characters we're using x as the delay, the millisecond delay between each one. And there are a bunch of programming projects also from the textbook. I've summarized them here in case you don't have access to the textbook. They're pretty, standard stuff. This one is using numbers convert, so you get the user to enter a Fahrenheit temperature and use this formula to convert to Celsius and output the result, maybe round it off nicely. And then the other one here is just a little word game. You get the user to enter their favorite color, food, and animal, and the name of a friend, and then you output this thing that uses what they entered to create a silly string. Okay, so there's a couple of other examples that you can try. Okay, so I want you to give that a try, and I should stop because I think this video is already too long. But I'll see you in the next video, which will be, I think, on graphics.